Welcome back to another episode of Freeform AI. My name is Michael. I do data engineering and machine learning at Databricks. I'm joined by my co-host. His name is
Ben Wilson. I build things that scare me at Databricks.
Yes, you now have a very clear fear of God. And Ben, I'm curious, what brought this fear of God into your life?
One of the more recent work streams I've been working on with a project that you and I both work on together.
Yes, exactly. So we're going to start off this episode talking a little bit about the Databricks Data and AI Summit, which was last week. Once this episode hits, it might be a few weeks old, but there were some really interesting announcements and some things caught me by surprise. And then we're also going to lead into a lecture from Stanford with our current CEO, Ali Gazdi, and talk about what context looks like in the world of AI today. So taking a step back, Data and AI Summit is our annual conference. I was there in person. Ben luckily was not. The keynote hall has over 10,000 seats. There were 32,000 people in person. It's a lot of fucking humans. And it was tremendously overwhelming. That said, it's very exciting. Databricks is a very innovative company. And in some of the prior summits, I've been absolutely floored by our announcements. And these I thought were pretty good as well. I think we've been actually, I'm not going to say more so I don't get in trouble. Anyway, one of the cool announcements that they mentioned was Genie Ontology. Genie is our suite of agents, and you can chat with your data. It can build stuff for you, and basically every chat interface that's like a managed agent in Databricks is now branded as Genie. And it used to be just a single feature, like as of last year. But as of last week, it's everything. And one of the key things that Ali pitched on stage is that AGI is here. And the key limiting factor for functionality is context. So, citing a stat that he mentioned in the Stanford lecture, about 95% of enterprise AI POCs fail. And so the question is, why is that? Well, if AGI is generally here, according to Ali, it must be something else. And he postulates that it is context. The LLMs don't know enough about your use case, about your processes, about your business to actually provide value. Ben, what's your take on that?
I agree. And we talked about it last week, and I think I wouldn't have agreed at that time, probably because my lack of faith in my own abilities on a project that I have been working on. And my tune has changed as of Friday at 4:45 p.m. last week.
Great. All right, so AGI is here, according to Ben. That's all we needed. If Ben blesses, then it must be true. But before we get really into it, I'm looking up Genie Ontology. And of course, the docs are not out yet. But God, Databricks, get it together. So for Genie Ontology, basically the vision here is that Databricks is a lakehouse platform. You have a bunch of different assets, whether it be structured, semi-structured, unstructured data in the lakehouse. Then the layer above it is Unity Catalog governance. So by properly governing everything and storing it under one roof, it's ripe for value extraction. And so the question is, all right, you can build a model off your data, but that requires typically a human intervention. And you can do all these other types of things that turn data into value. But the question is, how do you expose it to LLM-based interfaces and chatbots? And that's what Genie Ontology looks to do. It looks to basically create structure that is highly queryable, whether it be in a graph format or whatever structure underlying the data that is most conducive to querying, it'll do that. And we're not allowed to talk about like what that actually is, but it's very cool. And it should expose a lot of the data in the lakehouse for agentic capabilities. So that's that. Ben, we're working on this thing called Lemma. It's internal tooling for go-to-market teams. You're sort of doing the same thing, right? Do you mind walking us through your use case?
Yeah. So what was it? Like a month and a half ago, 2 months ago or something, we heard on our side the same thing of like, hey, in order to make all of our services more powerful, we have all of this rich data that our users actually generate or are generated on behalf of actions that they take with customers. They jump on a call, they get a call transcript, they get an email from them, that's data. And there's no real clean way with pre-existing technology such as RAG to take all of that and just give an LLM the ability to search over it. Because If anybody has ever looked at a call transcript that they're on with a customer or even with their buddy, if they choose to turn on transcript for that, you realize that the vast majority of information that's in those transcripts, things that are being discussed, it's not some linear path of information extraction. It's not like we're writing via the way that we're speaking to one another an easily digestible structure to a document. So like it would be probably more efficient if we did that, but that's just not how we behave as highly advanced primates. To say, okay, we're going to talk bullet point one. Let's cover all of that in brief detail. Let's make sure that we are logically flowing from an initial point of context until we hit a conclusion. And then we're going to talk about, topic point two. Usually what you get is a ton of ambiguity, or you get unfinished thoughts midway through. Topic shifts to something completely different. Sometimes resolution doesn't occur of like some topic. Or the worst case that I've seen is somebody talks through a bunch of topics about here's what we're going to talk about in this meeting. They list through like 10 bullet points and everybody kind of agrees. And you end up doing bullet point 1, then 7, then part of 4, and then you go to 5, and then you just pivot. And now you're doing bullet point 11, 12, and 13 in just some random order that was never covered. So when RAG tries to search for stuff, the chunking strategy that you're using, you might be getting so much additional context for matching particular terms from looking at a transcript that the LLM is trying to piece together a narrative based on that data, assuming that your re-ranker is not like trashing stuff that doesn't meet the requirements. So with RAG, that agent is automatically handicapped with regards to large amounts of information coming in from disparate references without proper context. It's getting just collections of bags of words that it has to reconstruct into meaning. That's when hallucination happens, or it's inferring something that just doesn't exist because it doesn't have the full picture. So we knew we wanted more accurate context based on these sort of raw data sources. And I knew I didn't want to do RAG because that's kind of been proven out that it sucks unless you have really clean data. So my approach was like twofold. First part is control what data comes in. And that's key because if you can imagine a solutions architect is talking to 10 different accounts, if in account 1, they're working on these work streams and there's some sort of context associated with that account. If you accidentally include account number 4 into account number 1, that derails the entire system. You're now introducing incorrect, misleading, irrelevant context into any sort of search query paradigm that you might be building. So that's the primary goal that I had. It's just to design the system to make it so that it's almost impossible to do that. It creates some UX friction, but that's actually intentional. You want it to be accurate more than anything else. And then the second part is, am I not as stupid as I think I am and potentially capable of creating a system where I can have extracted information from messy data in such a way that I can approach not getting to the concept of truth, but extracting claims that are going to be useful on their own. And that was like the phase 2 approach of building that system, which I think I finished that up like a month ago, and it was okay. It's like, yeah, it's fine. But on its own, it was just a summary of the entire document, followed by a list of facts or claims of what it extracted. And those are distilled. So it's like compressed representation of a lot of speech or text compressed down to 1 to 3 sentences of like the meat of what it was being talked about. And it was okay. What moved it, like the big epiphany that I had last week, was redid the way that the distillation worked. And this was, based on talking to our compatriots on the research side. We had some back and forth discussions about like what they're working on, what I was doing. We were sharing ideas. And the thing that really resonated with me was thinking about a problem that they were having about provenance. Like, where did this actual claim come from? What is the estimate of its accuracy, its factual claim based on corpus? So is this just a random fact that somebody mentioned that has nothing to do with the main body of topic that's being discussed? Or is this something that is highly relevant to the core of the idea that's being communicated? And how do we represent that in a data structure? And how do we provide attribution of like who said it, how many other people agreed with it, what is it in reference to its local context throughout a discussion or throughout a document? So I built that data structure, I stored it, and realized that I needed some means of hierarchical navigation within a UX so that somebody could even look at these things in a UI and understand without looking at just a page full of, here's 117,000 claims based on all the data that you loaded in. That's almost like a trolling UI to create something like that. So I was like, all right, I need hierarchical groupings. I need some sort of labels here. So that was part of that distillation. Like, tell me what, on a broad sense of these like 10 topics that information could be discussed under, where does this fall? Where does this claim fall? And that's the primary navigation in one part of the UI. And then I also wanted to extract out an unbounded set of facets, which is references to technology, references to architecture, things that a Databricks customer would be discussing with an account team. Could be something with billing, could be something with like security or personnel or whatever. So facets are huge. There's on the test that I ran of a bunch of data being uploaded, it generated tens of thousands of them. So that initial high level hierarchy combined with the facets, combined with the attribution and the true provenance of each fact, I loaded all that in and then turned on some special stuff in Postgres via a plugin that does like trigram groupings and some semantic search over things, and built a REST API around it, and then built a UI interface. And then I started asking it questions. And within 10 minutes of me playing around with it, I just kind of slid my chair back and stared into the distance through the walls of my house to the horizon and wondered, what the fuck did I just build? Because I'm asking questions that have no bearing on any recorded information that was in this corpus, and just the direct search API is returning the most relevant results. And then we also have RAG on that, so I can search the raw sources as well. And I took the exact same query terms and ran that exact same question through RAG, and it returned nonsense, like not useful information, because it was just matching on stuff that was not relevant to the question because the question wasn't related to the actual raw data that we had. And I just kind of sat back and I'm like, did I just make a non-shit context service here?
Sounds like it.
I was like, hang on, I got to hook an agent up to this and see what a frontier model can do with having access to this. So I did that and started just watching what it was doing, effectively turning on telemetry and watching like the tracing of what it's doing. And it started to rapidly figure out like what this search API was capable of doing. And it was returning and then inferring stuff. And the most telling one was the topic that we had a couple of weeks ago about the Agora, all the call transcripts from that. And I started asking questions about philosophy of software engineering and like, what does doing work well actually mean? And what does it mean to like design good architecture? We're not like discussing those topics on the Agora. We are, but through the lens of some deadpan absurd comedy, as well as some deep philosophical thought that is more concrete in implementation. And the results and what the frontier model was able to do with the search result return, it was able to make claims based on how I run those things about my core personality. and like why, like what do I value, like as a human working with other humans. And it was so unsettling to me. Like this thing is like analyzing my style and providing a deep analysis of what like internal theory is of what mentorship is and the concept of apprenticeship and like why I'm doing this stuff. And it just made me stare into the middle distance, man. I was like, this thing is very capable of
Yeah.
answering very complex questions, but actually nailing it.
Yeah.
And then, of
Okay.
course, as a blind test, I was like, all right, I'm just going to hit the API on its own, ask these same questions. It's just generic nonsense. It's just like, oh, this is what was in your training data. Thanks for the theory.
Yeah. Okay. So let's take a massive step back. That's a great case study, but I think it'd be helpful to sort of understand the context of all this. So, as we alluded to, LLMs only know what they've been trained on, and context augmentation is a really important field of study. So, you can put stuff into a system prompt, but the issue with that is the system prompt is limited. If it gets long, the LLM gets confused, and it's hard to keep the system prompt up to date sometimes. So, along comes RAG. RAG is where you store chunks of context in a vector search index. You then do semantic lookups, basically calculating the semantic similarity between what was sent and with what's in the database. And it'll return the top K or the top N, the top total like number of chunks. You can re-rank them, you can modify them, you can summarize them, and you just shoot that back into LLM's chat. And now it has context and it sort of knows what to do with that. So, question number one, Ben. This seems like it's a step beyond RAG.
Yeah.
Why?
Because it's approaching the concept of knowledge the same way that we do. And we have socially evolved to do this information compression. Nobody sits there and memorizes every source of information. Our brains aren't even that represent our attachment to ideas and concepts. We build mental models of this is what this topic is. We distill it down into its core components. Some of it, sometimes for some people, it's visual or auditory, or it's some sort of spatial relationship in your head about like how these things interrelate to one another. And for our capabilities of information recall, we're leveraging that, like these associations, and we're building, deeper and richer contextual awareness of a topic when we talk about it. And at its most extreme point, we can, the old saying, a picture is worth 1,000 words. Why is that? It's because we're doing that compression at an extreme rate. We notice things in pictures and we infer things from it because of these totems that we build.
Exactly. It's a data representation problem. So when we think about text, that is a data representation. When we think about images, that's a data representation. Audio as well. And it all represents like sort of the real world. And you can get really philosophical and really meta really fast as whether our like observations of the real world is actually what's happening outside of our heads. But we're not going to do that today for brevity purposes. But it's really important to understand that text is just language or is just representation of knowledge. And Ben, what you're doing is you're finding more efficient and more correct representations of knowledge via compression, via text. Like,
Mm-hmm.
what does that actually look like?
Yeah, the distillation is if I wanted to basically take a white paper and fairly dense, fairly verbose, most of them are, and compress down the core idea of what that is into 3 sentences. Like it's basically creating an abstract, but a compressed abstract of like, this is why this is and why it exists. And if you can do that in 3 or 4 sentences or so, you've effectively compressed the concept of that idea. You're not throwing away the raw data though. So what you're doing is you're taking within that white paper, maybe there's like 10 main ideas spread across hundreds of thousands of lines of text in a big white paper. And you'll look for what are those 10 main concepts, summarize those down into a couple of sentences, and maintain that the contextual awareness of how does that relate to the other 10, or does it relate to the other 10? And then what is the ultimate and penultimate references of the raw source that can be included along with that to provide additional, relevant context to it. And that level of like distilling the information down into the minimal amount of highly efficient summarized text is really the key in the system that I built of here's how to do like not just summarize this thing in like a paragraph, but summarize the ideas, the ones that are really important, and then just don't worry about the rest.
Why can't you just throw everything into the context of the LLM? First question. And then second question, why are we pre-calculating this? Because I think answers to both is the value proposition of this solution.
So throwing the test that I did with the Agora, it's hundreds and hundreds of pages of like call transcripts text. It's just, you can't even load it all into a context window. It blows through the tokens. So it's too much information for the LLM. It's also too much information for a human. Like if I asked you, hey, Michael, go and read all the transcripts, your first reaction would be no. Your second reaction would be like, why? And if you needed to do it, you'd be like, all right, I'm just going to throw this into an LLM and tell it to summarize each of these. And it'll summarize, it would summarize the call as a whole. It would be like, here's what was discussed. And, here's the overall theme of this particular call that was had. That process of summarizing that on its own is going to drop out all of the interesting bits of it. You're going to lose so much information by just compressing the entire thing. So instead, by doing that distillation phase, it's basically telling the LLM, find truth in this, find interesting things. And for each interesting thing that you find, capture its provenance. And all of a sudden, when you look at that, you realize this hour and 30-minute discussion does have a theme, and we do capture the overall theme, but it also has 37 other themes going on, and they all relate to one another. And there's all, important things that are happening in here, but we're not just taking a slice of, well, Ben said this really interesting thing, and here's the excerpt of that. That has no context to the overall discussion. So instead, distillation is saying, summarize that idea within the context of what was actually being discussed. And these LLMs that are doing the distillation phase, they kind of understand the broader picture when you tell it to do that. It's capable of doing that. So that at retrieval time, it's like, I get the main story here of like why this was even spoken about.
Got it. So distillation is required because LLMs have finite context. Just like a human, it can't remember everything, and it takes time to read through all of the transcripts or whatever your source documentation is and understand what the hell is going on. Cool. So that's my answer to question one. For question two, why are we pre-computing it? Why can't we do this just in time?
Not only is it insanely slow and expensive to do that just in time, and it wouldn't be just in time, it would be, here's a 60-second lag time for just doing one document. So economy of scale, you want to be able to compute it once, read it many times. But the other aspect is, there's several other aspects, but its distillation is inferring things that are not entirely obvious. So it's kind of capable of understanding the underlying ideas that are being expressed and what their motivation would be. And it records that within the distillation, which is kind of creepy when you think about it. It's like, oh, it's reading between the lines here and then summarizing that, like the core idea. The other thing is if you're ingesting stuff that's about like a B2B contract, like the core purpose of what we're building, you could have 1,000 documents. Some are call transcripts, some are emails, some are whatever. And you could have one claim being made in 50 of those repeatedly. They're talking about, oh, what's the plan on this thing that we're working on? And this project you're working on is 2 months long. That could be brought up 50 times easily. Are all of those equally relevant? No. the fact that the thing is being worked on and there's a temporal relationship to it and there's like status updates to it, that's what's important. So how do you group those together to say these are all related to the same thing, and don't present them to an LLM as saying, hey, here's 50 claims of the exact same thing. That's what you get with RAG. Query, like, what's the status on this? And it would just be like, all right, here's 50 mentions of this thing. And if you're doing like re-ranking and stuff, you might toss some of those out, but the LLM is just going to see effectively dupes being sent to it. So it's not going to have the rich context of everything else that's going around. And the other thing that you want to do for pre-compute is the fact that you could have like claims that are being made that contradict to one another. We could even take our transcripts of like this podcast as an example. Last week, what we were talking about, AGI's not here. And then this week, we're talking about like, maybe it is here, provided that it has the right information and it has a better model of reality. It can respond in a truly terrifyingly competent way.
Exactly.
So there's a temporal association with our beliefs and our conjectures and our claims. How do you preserve that? To say like, this has evolved, instead of just saying, what is the latest state of what this is? So you pre-compute those beforehand so that you can do that grouping
Exactly.
in the back end, so that at query time, it has as much relevant context as possible.
Yeah, so in the Stanford lecture, it's called Economics of the AI Supercycle. It's class number 4 with Ali. Feel free to check it out. But really, really cool lecture, and I ended up listening to like 4 more after that. One of the key things that Ali cited, and generally this is the number, I forget, I don't know how accurate it was, but about 95% of enterprise AI POCs or proofs of concept fail. So we as a data and AI company are out there pitching all these enterprise customers saying AI is here, and same with all the AI companies. And a lot of the consumers of them are a little confused because they're not seeing real value being generated from all these solutions. And Ali cites that it's a lack of context. So if we were going to be generating an email, that's one of the key use cases. You need so much information about who's the sender, who's the receiver, what is the account doing, what's the state of the deal that we're talking about, and all those other things. So Ben, do you think your solution solves this?
I think we have a couple of subsystems that are working towards doing that. And the who's the customer, that's coming this week. That's what Owen and I were working on with the account profile. Like, who is this person? What's their job title? And why are they even on these emails? And with references to like the state of things, like what's the state of this project and what are the blockers and what are the next steps? That's account context. That's this system that we were just talking about. And with all of this, when you start injecting that into a task that you want it to do, say like, hey, generate an email response based on this very vague, like there's definitely context that's missing from the body of the email. Nobody writes emails saying like, you know, in response to the question that you asked at our last meeting, allow me to first elucidate the last 3 months of our engagement. Like nobody writes a 30-page email like that. We keep the context in our heads. We have short, long-term, medium-term memory where we can access like, oh yeah, what were they doing? Oh yeah, I remember we're talking about this. So the goal of these subsystems that we're working on in Lemma is how do we provide that to the LLM, that same context that a human would have to respond to that email. They know what this is referring to. Because if you don't do that and you just give it RAG, or even worse, you just say, hey, LLM, just generate a draft response to this, all you're going to get is like pure insanity. It's going to just invent stuff that it's going to infer from what it thinks it understands about the language being provided to it.
Exactly. So I think getting into the implementation details is probably bordering on intellectual property. So we'll not do that in that much depth. But I think there's a lot of cool lessons that you and I have both learned along the way, specifically you, on building this type of solution. So I propose we take turns and we list 3 tips each on approaching this context injection problem at your organization. I will kick it off. The first one that I've been banging my head against for the past whatever number of months and continue to do is governance and access. So Databricks is a pretty advanced tech company, but it's pretty big now, and there's a little bit of bureaucracy, and rightfully so. The security is important at this scale, and it is also always important. So if we want access to Salesforce, or we want access to Logfood, which is our central Databricks repository or workspace that has all the sensitive data, we need to go through a bunch of approvals. And we also need to go through the proper steps to make sure that our security posture when querying is sufficiently hard. So I would spend a lot of time figuring out how best to centrally govern these things. Databricks just announced a product that is supposed to do this, but just having centralized governance and centralized access patterns, I think, is a prerequisite to any of this work.
I would say to follow on with that, if you're accessing stuff that is sensitive on behalf of a user, treat their access in such a way that you can't even see it as a developer. So that means strong encryption at rest, and decryption should be authorized through stuff like OAuth. And only that user should be the one who can actually see that. That's how we've built Lemma. We can do things like the server can do things provided that the user opts into it, where we can do things on behalf of a user. But if I'm not that user, I should not be able to see their stuff. Like, you test on your own account and see where things are broken and fix it. But when it comes to a user experience, log their behavior so that you can debug stuff, but don't ever have the ability to see their stuff.
Yep. Cool. My next one is find your MVP quickly. We have absolutely failed at this with Lemma. I think that this is a big bet feature, and it takes some sort of like waterfall style development where you assign multiple sprints. But I do think we could have gotten signal on whether the context DB would be a useful feature much sooner. And I think the entire project is oriented around the context DB being valuable. So if it's not valuable, the project gets killed, kind of. But it would have been nice to have signal on that earlier. So thinking critically about where the gaps would exist for your use cases. So if you're drafting emails, find some emails where context would really, really help that email. Or if you're writing a meeting prep document, find a use case where context would really, really help the meeting prep document. And use that as a supervised or even unsupervised set to anchor whether your context DB is adding value.
And then scale is something to think about. If you're building some sort of semantic distillation layer on source data, particularly very messy data that contains a lot of key information, be very careful about how you do that ingestion. You definitely want to do stuff like schema versioning and make sure that you don't have to reload the universe every time you want to make an improvement. So think about ways to gracefully do that and sequentially do that over time. But LLM calls get very expensive, and they also are generally rate limited. So thinking about it, structures where you can trickle in the data instead of saying, all right, we're going to do like a batch load of everything from the beginning of time and hope that it's good. You're just going to be hitting like retry limits, and then you're going to have to, build weird workarounds. So think about queuing in order to ingest.
Yep. Queuing. That is a great one. All right. Well, my final one, and there's a bunch to choose from, but I think that I need another second. Ben, do you have your third one?
Not yet.
God damn
Still
it.
thinking.
Nice weather we're having. So I honestly think that those are some of the key aspects. Basically, if you create a clear MVP and clear use case that you can evaluate, you now sort of have constrained the problem to understand what is going to be adding value. From there, a lot of it is implementation. So creating really robust access and then also encrypting sensitive information, making sure it can scale. My final thing, I've found it really, really interesting to observe the shit processes that this reveals.
Oh, yeah.
And as AI starts like sort of reviewing and understanding how organizations actually work, a lot of the reasons why it can't do the job is because of legacy or inefficient or just non AI friendly workflows. So if the data is wrong in all of your source systems, there's no freaking way the context DB is going to solve that. And if it lives in someone's head and it's not actually in a digital system, that's also a big challenge. So with all this, I think it's really important to, as you are building a technical solution to meet the real world, I also think it's important to revisit the real world and see how we can make that meet the technical.
I would agree. My final one is be careful what you ingest. So the way that we've approached it is reject when uncertain, require human confirmation. If you just ingest the world, everything that you have in your data stores, look at a company that heavily uses Confluence, for instance, and you just say, we're just going to take all of Confluence and just like load it in. How much junk is in there? Outdated stuff. Nobody ever goes and cleans stuff up unless there's some, mandated, it's just a dumping ground of garbage. We need to clean this up. So the whole company goes and like cleans up Confluence. And then 6 months later, it's still a dumping ground again, or it became another one. So having stuff like lightweight classifiers that have strict requirements of like, is this data useful? Is it relevant to the topic that we think it's relevant to? And is it providing any real meaning? In our ingester right now, if you send a document to it, there's a classifier that says like, does this belong to the account that we're trying to map it to? Part of that classifier, and there's actually several classifiers, but another one is there any meaningful content in this? Is this actually useful from an epistemic perspective? Can I glean any information from this? And if no, it just rejects processing of it. It's like, there's just garbage in here, nothing useful. And what's also kind of funny is I've run that on call transcripts of the people have submitted for me to test on. And you look at the timestamp and you're like, you were on a call for an hour with a customer and the classifier said there's nothing useful to extract from this. And I'm like, hang on a second, there might be a bug here. And then I go read the transcript. I'm like, no, the classifier was right. This was an hour of a giant ball of nothing. Like no information was conveyed here. It was just dancing around business logistics. So the classifier's like, I can't, there's no claim to extract here. So, and it's amusing when you think about stuff like that is like, maybe we can provide some sort of indicator within the UI to let the person know that this call was a waste of time. Like try to avoid calls that have no real purpose to them.
Yeah, audit the real world, 100%. Okay, cool. Very interesting episode. Again, we had to keep it sort of high level due to intellectual property, but hopefully this thing works. We'll know in the next few weeks, and then we'll also see if it can scale out to all the use cases we have planned for Lemma in the next few months. So to summarize, AGI may or may not be here. It doesn't really matter, but the LLMs are very smart these days. And the current limitation of functionality is context. So understanding your use case and your business. Skills cannot recompute context just in time because it's too expensive. It takes too long. It needs to be sort of this external queryable database, or like you could even maybe think of like a markdown file, but that doesn't work. But it just needs to be a queryable system. So if you're looking to realize the value of AI in your organization, you do need a context related system. Some tips when implementing this: centralize the access paradigm for auditing, encrypt sensitive context so devs can't read someone else's emails, create a set of evaluation cases that anchor you on the truth. Be careful what you ingest. If it doesn't look good, just leave it out. Think about scaling. This is going to be a lot of LLM calls, and so watch the price tag. And then finally, as you go through all of this, there's going to be indications of inefficient processes in the real world. Don't be afraid to review them and change them. And I think that's it.
Yep.
Cool. Anything else? All right. Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
and have a good day, everyone.
We'll catch you next time.